Okay, so I thought about, while I was waiting for the other video to finish downloading, I thought about a better way to explain what's happening here. So remember how we talked about it being on the inside, and since it was on the inside, it behaves opposite of what we think. We think multiply by 2, so we think a stretch of 2, but it's not a stretch of 2. We're compressing it horizontally. So that means what was right here is being pressed this way. It's being pressed horizontally. It's being pressed horizontally. So we're compressing it right and left. We're taking our compression and our thing right here, and we're just squishing it toward each other. Kind of like if your hands were spread out like this and then they are pressing it in, okay? So that's why it's a compression. Another way to think about it is what right in this point right here, it was the 0.22. If we compress it vertically, then to get the same y value, the y value of 2, we only need half as much x value. So you can see right there that my x value, if I can get the point right on it, there you go. So the point was at 2,2, but take half of the x value to get the same y value. That's what that compression does. Okay, so the y value right here is negative 2,2, and that the absolute value of the 2x causes me to take half of the x value to get the same y value. So we've pressed it in, okay? That's what a vertical compression is. I know it's confusing, but just keep practicing and it starts making more sense. Okay, so we said it. The graph changes, graph the function. We did that. What transformations did your graph show? It showed for, let me get my pen back. Okay. For this one, it was a horizontal shift. Remember, inside changes. Remember, inside changes are horizontal. Horizontal goes this way, so it's plus and minus. So it said minus, so it's a horizontal shift 3 right. Okay. This one, remember, had 2 parameter changes. One parameter change right there, one parameter change that right there. That caused a horizontal, because it's inside. And when you say horizontal, think right to left and left to right. So it flipped it. A horizontal reflection. Okay, that's what we call, anytime it's a negative, a horizontal reflection. And the 2 right here caused a horizontal. Oh, my thing is wobbly because I'm sitting on a cord. A horizontal. And think, we see times 2, so you want to say stretch, but do the opposite, compression. By a half. My x values got half as small as they were. Okay, so it went like this. Oh, actually, it went down like this, didn't it? No, it didn't. It didn't go down. It went up like this. Okay. Clear as mud, I know. So let's see what we can do. So use the graphs from item 2 to predict the transformation. Okay, it says, here we go. Here's our prediction. So our predictions are, where is this? It's an inside change. Inside change is horizontal. Plus, minus, we see plus, so we're going to predict left 2. Okay, so parent function, didn't change, did it? Parent function looks like this. The one with the parameter change, left 2. Okay, now they want us to sum it up. horizontal translations occurs on the independent replace with, okay. So if you see x plus k, that means k is positive. Describe how it will change. K units to the, remember, inside horizontal, horizontal moves left and right, plus minus. So if you see that it's positive, it's going to move to the left. Okay? If you see that it's negative, okay, then that means, what in the world is happening? That's crazy. Okay, so if it's negative, then that means that we've moved k units to the right. Why? Because if it's inside and it's horizontal, plus and minus, so if we see minus, it means it moves to the right. Okay. All right, so graph each function. We should be able to graph them without having to check it on the calculator, but you should always go back and check it on the calculator, Desmos. What do we see? Inside, horizontal, it says -4, so we need to move to the right 4. 1, 2, 3, 4. The absolute value graph has a slope of 1 and -1 on each side. Okay. Where is that? Horizontal. It's inside, so we know that that means it's horizontal. Plus, minus. It says plus, so we need to move left 5. Okay, so here it is. 1, 2, 3, 4, 5. They moved the graph over for us. Wasn't that nice? Okay. We have a slope of 1. Okay, use the coordinate grid at the right, graph the parent function. Okay, I'm going to graph the parent function in red because that's what I've been using the whole time. Parent function, parent function. Okay, the inside change, so that means I'm going to be pressing it in. I'm going to be pressing it in, compressing it this way. Okay, or think about it being on the outside, pushing that way. Okay, so this is going to move, and it's going to move. I'm going to take each one of the x values, and I'm going to half them. Okay, so this is a value of 1, so I'm going to move halfway. This is at 2, so I'm going to move to 1. This is at 3, so I'm going to move to 1.5. This one's at 4, so I'm going to move to 2. 1, 2, 3. Oh, that one's at 3, so I'm going to move to 1.5. This one's at 4, so I'm going to move it to 2. Okay, so you see how it's pressing in. Should look something like that. Describe the graph of g of x. G of x is the transformed one. So that was a horizontal, because it's inside, so it's a horizontal. It's multiplication, so multiplication is, in this case, it's a compression. Horizontal compression by a half. Okay, let's see what the next one is. Okay, so it looks like, okay, so let me cut and paste this one real quick. So what's that one going to do? If you're looking at that one real quick. Okay, so real quick, it's going to do the opposite. This is going to double everything. So it's inside, it's horizontal, and instead of dividing by 2 or making it half, it's going to make it twice as big. So it's a stretch by 2. I'm out of time again.